And here.
Hello.
Hello, ma'am. How are you?
I'm fine. Who is this? Fareed?
Oh, ma'am, Mohammed Bilal.
Muhammad.
अस्सलाम वालेकुम मैम।
अभी नाम भी बोला करो।
यस मैम।
Okay. Hello, Amelia.
Yes, ma'am.
Hello, Chand.
Hi, ma'am.
Hello, Chand Khushi.
Hello, ma'am.
Hello, Sania.
Yes, ma'am.
Sania, are you sleeping?
Yes, ma'am.
Yes, ma'am. Hello, Ibrahim.
मैम उठ गई हूँ.
अस्सलाम वालेकुम मैम।
Walaikum salam. Hello, Maiza.
Hello, ma'am.
Hello, Rana Shahbaz. राना शहबाज कहाँ है? Hello, Rana Shahbaz. Are you there? Yusuf Patras, are you there? We don't know. So log in.
मैम present.
हाँ?
यूसुफ इधर मैम present.
कौन बोल रहा है?
यूसुफ मैम.
Okay. Okay, right. So let's start. I'm going.
मेरी रह गई।
कौन रह गया?
मुआज।
मुआज कहाँ है? मुआज, yes, you're there. Okay.
मैम मेरी भी नहीं हुई. जरश मैम.
जरश, okay. ठीक है, बोला करो ना नाम लेके. Whenever I talk to you, please say your name, okay? Because I cannot see you. ठीक है? समझ आ रही है ना?
Okay, ma'am.
Yeah. Okay, so what are we supposed to do? We're going to start center of mass and linear momentum, okay? Can you see it? Can you see what
Yes,
happened?
ma'am. Yes, ma'am.
Good. So what do you understand by center of mass? What do you understand by the concept of center of mass? Let's talk about this. What is the center of mass? It's also written as COM, right? So what is center of mass? Who will answer this? What is linear momentum? Come on. I'm going to take the attendance again, and meanwhile you can think about the answer, okay? ठीक है? Okay. Sarmad, Amar, Abu Bakr, Fatma Babar, Usman Bajwa, Anam Basharat, Bilal Muhammad.
Yes, ma'am.
Hamza Dar, Fariduddin.
Yes, ma'am.
Kessler. Zaresh.
Yes, ma'am.
Haris.
यस मैम।
Muaz.
यस मैम।
Okay. Ibrahim.
प्रेजेंट मैम।
Huma. Alina Khalid. Hunain. Muhammad Hunain. Rana Shehbaz. Sania Ahmed.
Present, ma'am.
Arisha Khurram. Chand Khushi.
Present, ma'am.
Maiza Asif.
Yes, ma'am.
Yusuf Patras.
Yes मैम. क्लास में हूँ.
यूसुफ आप बोलते नहीं हो अक्सर.
मैम वो मेरा इंटरनेट स्लो है तो प्रेस करे तो बटन प्रेस नहीं हो रहा था.
अबीरा मुबशर. नादिया मुख्तार. हयान अहमद. हाँ
मैम सुहेब ताहिर.
सुहेब ताहिर, आप बाद में एंटर होके शोर मचा रहे हो. नादिया मुख्तार,
मैम वो मैं वॉशरूम में था, लेट हो गया।
हयान अहमद, शेरल नदीम, अशरेब, हुदा जहूर, अमिलिया.
Present, ma'am.
Okay. And Bisma Shabbir, Sadiqullah, Sohaib Tahir,
मैम प्रेजेंट।
अच्छा, Talha Muhammad, and Ali Zulkarnain. Okay, so I come back to the question I left you with. What is the center of mass? Who will answer this? I'll give you 1 point.
मैम
कौन
सेंटर
बोल
ऑफ
रहा है?
मास
पहले नाम बोला करो.
मैम मोहम्मद फरीद
जी फरीद.
मैम द पॉइंट फ्रॉम वेयर द मिडल पॉइंट फ्रॉम वेयर ऑल द अदर मैम जहाँ से बाकी मास की जो होगी डायरेक्शन वो इक्वल होगी मतलब बी इट्स अ सेंटर पॉइंट फ्रॉम इक्वल डिस्ट्रीब्यूशन ऑफ ऑल द मास ऑफ द बॉडी ऑफ द रिजिड बॉडी.
Can you give me an example?
For example, the middle circle, the middle point of the circle is the center of mass of the circle.
Okay. Anyone else would give like to give a try? चलो ट्राई करने में कोई हरज नहीं है. I give you credit for trying also. Okay.
बोल तो.
Who would like to try? Come on. Have you never come across the concept of center of mass? I'm sure you did when you were in matric or O levels or FSC. Yes. Who else would like to give a try? Huh?
Haris, ma'am, it is the point where everything is balanced.
Ah, yes. Okay. Can you give me an example?
Anything from a square can be balanced at its center.
Anything?
A square can be balanced at its center. A circle.
Square. Are you saying square?
Yes, ma'am. Yes, ma'am.
Would anyone else like to try? Yes. What are the, for example, can you give me an example of an activity where you need to understand the concept of center of mass to help you perform that activity? Example? Think about it. Why do we need this concept? You know, because this is a course on mechanics, which is related to your everyday life. It's related to motion, it's related to vehicles, it's related to sports, it's related to dance, it's related to gymnastics, it's related to even ballistics, you know, like for example, when an accident happens. So in order to perform forensic ballistics, normally a person is hired who is an expert in mechanics who can come and explain how it happened and what can be the scientific explanation to find the truth about how it happened, right? You understand this? So there are many different ways of looking at it. All these concepts are very relevant. You've come across them in your life. You've definitely come across them knowingly or unknowingly. You've utilized them. And if you understand them better, you will be able to perform those activities better. In addition to that, you've also studied them at some level in school and at some level in your metric, O level, FSC, whatever you studied before you came here. Okay. So if you can come up with another example or another explanation, I would welcome that. So the second concept we are talking about is linear momentum. So who would like to tell us something about linear momentum?
Ma'am.
Who is this?
Ma'am, Sania Ahmed.
Sania Ahmed, yes. Tell me.
Sania Ahmed.
Yes.
Ma'am, linear momentum is basically the product of mass and velocity.
Okay.
It has basically the first.
It has what?
law के अगा it remains constant unless कोई force उस पे act नहीं करती.
What remains constant? Please complete your sentence properly. Otherwise, it makes no sense.
the momentum जो किसी ऑब्जेक्ट का मोमेंटम है वो कांस्टेंट रहता है unless कि कोई उस पे फोर्स एक्ट नहीं करती.
अच्छा, what's the symbol for momentum?
जैसे न्यूटन it is P से मैम.
हाँ, ठीक है. Okay, so now we will try to understand these concepts properly. So all of you made an attempt, and that's good. But now we need to understand them correctly and properly, and therefore that's what this chapter is about, right? Okay, and you will also remember them, I'm sure, from your previous study that you've done in physics. So this is a concept, like I said, which is very relevant to motion, to cars, to sports, to dance, to gymnastics, and all that. For example, when you see a man walking on a rope, you know that this is a very difficult and dangerous activity many times. And he has to have a very good understanding of his center of mass, because otherwise he will not be able to balance himself. So you can see very strange acts of gymnastics that are very surprising many a times, but the person performing those acts has mastered the art of balancing his center of mass, his or her center of mass. Similarly, dance activities like ballet dance, ballerina dance, for example. Ballerina dance is again a very sophisticated technique of dance where you have to balance your center of mass in order to perform the different steps. So there are many examples. Now, if you look at the page that I'm sharing with you, you can see a baseball bat. Now you can also see that every object has a center of mass. So far, the mechanics that we were talking about was about, we assumed that the body we were talking about was a single particle. But in everyday life, every body is not a single particle, rather it is a combination of a number of particles, right? So for example, if we look at a baseball bat is not a single particle. In fact, it is a combination of a large number of particles, and therefore we know that if we throw a ball in the air, the motion it covers and the path it's followed is known as projectile motion, and this path is known as a parabolic path. But the bat, when we throw a bat, for example, the bat is not one particle, it's not a single particle, and therefore the motion will be much more complex than this. Similarly, the human body is a system of particles, it's not a single particle. So again, you have to then refine your understanding of center of mass. So let's see how we can do this. So let us define the center of mass of a system of particles such as a person, a human being. And then we will be, if we develop an understanding of center of mass, we will be able to predict the possible motion of that system, right? So that's what you need to understand in order to perform any of these activities. So this is the official formal definition given here. The center of mass of a system of particles is a point that moves as though all of the system's mass were concentrated there, and all external forces are applied there. So it's a point in a body that behaves as if all the mass of the body is concentrated there, and also that any force that is applied, it behaves like it is applied at that point which we call the center of mass. Okay, now we have discussed some examples. Let's look at some formula in order to find the center of mass. So the first example we consider is two masses. Let us consider at one mass m1, this is mass number 1, and the second mass m2, this is mass number 2. Now we can see that the distance between the two masses is d, and therefore we have to find the center of mass. And the mass m1 has been, this we have seen that these two masses have been placed in the xy coordinate system. So you can see the distance has been taken along the x-axis. So the mass m1 has been placed on the origin of the xy system, which is considered as the 0 point, and the distance of the center of mass from the origin has been represented with xcom, which we're using to represent the center of mass. So how will we find the center of mass for this? This is the formula that we will use for this case is given here, which is xcom is equal to mass number 2 divided by the sum of the two masses m1 and m2 multiplied by the distance between them. Another point that you should notice is that mass m1, in this case, the mass M1 is not equal to the mass M2. What will happen if the mass M1 is equal to M2? Who can answer this? What will happen if the mass M1 is equal to M2? What will happen if the mass M... Okay, my question to you is number one, if M1 is equal to M2, what happens? The question number two is if M2 is equal to 0. If M2 is equal to 0 and we put 0 in this equation, then we will get that the center of mass XCOM will be equal to 0. It means the center of mass will be at the origin, because it means M2 is 0, means this mass does not exist, and therefore the center of mass will be at the point where we have the mass M1. Is that clear? Because if you put M2 is equal to 0 in this equation, the whole right hand side of the equation becomes 0, and the center of mass distance from the origin becomes 0, and hence the center of mass is at 0. Now the second question was if M1 is equal to M2. If M1 is equal to M2, let us say that we can represent it by the same symbol, which is M. If we do this in this equation, then this will be equal to M divided by 2M multiplied by D. This means this is equal to D over 2. If the two masses are completely equal to each other, then the center of mass will be at the central point between these 2 points. So it will be at half the distance that we have here. So these are some cases that you might have noticed from everyday life. You might have remembered that there was an experiment that was performed at metric levels, sometimes at FSC levels, in which you had to balance a rod. Do you remember that? You had a rod and you had to balance it, and you had to put weights on both sides, and you saw what happened when you increase the weight and when you decrease the weight and when you change the distance. Does anyone remember that experiment?
Yes, ma'am.
Yaad hai na? So again, this is what we are discussing here. Okay, the second thing you can try to understand, for example, that rod is similar to the concept of a seesaw. When you play in the park, when children are playing in a park, they very well understand these concepts, or although they might not be using the same terms or the same words, but they do understand them. They do understand how they will balance the seesaw, or even all these concepts that you use in the playground. Some children have really mastered them, and that's why they're very good at doing these activities. Okay, so it doesn't matter if they know the terminology or the formulas or not, but they do understand how they have to balance their center of mass and how they have to position themselves in order to get more fun out of the activity. Okay, so and then when you go to sports, then you have to understand these concepts as a professional. If coaches normally explain these concepts, they might not use physics terms or formulas, but they do use these concepts and explain at the position you should take, how you should balance yourself, and different aspects, how you can attain maximum benefit, or how you can master the technique of the sport that you're playing. Okay, so it all matters. Okay, so now the first case was the case when the mass M1 was placed at position 0, which is the origin. Now we look at the second case. The second case is the case when we place the mass M1 a little away from the origin. Okay, so now you look at the second part of the figure, you will see that the mass M1 is at a distance x1 from the origin. The mass M2 is at a distance d from mass M1 and at a distance x1 plus d from the origin. Now the center of mass is at some point between M1 and M2, and this distance of the center of mass from the origin is represented by XCOM. And the positions of the two masses are given by x1 and x2 with respect to the origin. So this is the second part, B part of the figure. Now, if for this figure, the formula that will be applicable is given over here. This formula you can see in the first formula, there was only M2 here. But in this formula, you have to include M1 also, because its position is not at 0. In the first formula, you can use this formula for the first diagram as well. But in that case, x1 was 0. So if you put x1 0, this term becomes 0, and you're just left with the m2 term, and the formula becomes the same as the above formula that we just discussed before. But if, for example, x1 and x2 do have a value, then you have to use this formula. Okay. Now, when you use this formula, you can also rewrite it in this way, where capital M, this sum m1 plus m2 can be written as capital M. So m1 plus m2 is equal to capital M. Okay. And so if you replace this here, you get this formula. Now, this is an example for explanation and understanding using two particles, but in reality, in everyday life, systems or bodies are not composed of just two particles. They're composed of a large number of particles. So therefore, if you have a large number of particles, the formula remains the same. So you have m1 plus m2 plus m3 plus m4 up to mn. We don't know n can be a large number starting from 1 to n. And capital M is the sum of all these masses. So we can write the combined formula with the sigma sign. You know, this capital sigma sign means a summation sign, where we apply the same formula, but we make a summation over n values. Okay. So again, we know that everyday life, we don't have just x-axis and y-axis, rather we have three-dimensional space. So we have x-axis, y-axis, and z-axis. So the positions can be defined in terms of x, y, and z. And again, we know that we've been talking about vectors. So if we include the direction, then we can define these in terms of vectors, and we can write the equation in vector form using the vector notation. So this is how it comes out to be. So it depends on what's relevant, what's required, what's asked. Now, we've talked about the summation sign, and we've also talked previously that the summation sign, if the number of particles becomes very large, then the summation sign changes to an integral sign. So this can also be written as an integral sign, right? We've talked about this before. Okay, so these are the formulas that we have. And again, we can also define this in terms of density. We know that rho is a symbol that's used to define density. And density is defined as mass divided by volume. Okay. This was again very basic. You've done this in school. So this is how density is defined. And in terms of density also, this formula can be written. So now let's talk about Newton's second law for a system of particles. Initially, when we talked about Newton's second law, we were considering a single particle. But now we are going to talk about Newton's second law for a system of particles. So if we have a system of particles, then we will apply Newton's second law to the center of mass of the particle. Because according to the definition of system of particles, we said that the forces will act, all the forces applied will act as if they're applied at the center of mass. And therefore, F net, which is the net force that is applied, will be equal to capital M, which is the sum of all the masses of all the particles, and then the acceleration of the center of mass. So this becomes the Newton's second law. Simply in the beginning, we just studied F is equal to ma, but now we have defined that if there are a large number of particles, then it becomes F net is equal to m multiplied by the m, again changes to capital M, the sum of all the masses, and a changes to a center of mass. So this, you get this equation. Okay. Now, these are important points to note. F net is the net force of all external forces that act on the system. Okay, so forces on one part of the system from another part of the system, internal forces, are not included in equation 9.14. Okay, so these are external forces and not internal forces. We've talked about that before. M is the total mass of the system. Okay, so it is assumed that the system is closed, that no mass is entering or leaving the system. Okay. And number 3, that a com is the acceleration of the center of mass of the system. Okay, so using this, we can write this equation in terms of the x, y, and z components. Okay. So this is the example of the ballerina we talked about. A ballerina has to understand where her center of mass is, and then she will be able to balance herself and perform the acts and the steps that we all find difficult to perform. So you can see the red dot represents her center of mass. You can see that as she changes the positioning of her arms, her center of mass is changed. Okay, so again, how you're going to place your arms again plays a role in changing your center of mass. I give you an example of a man walking on the rope. You will see that sometimes that man is holding a stick or something. So that also helps change his center of mass, right? Okay, so these are again the same equations we studied above. And like we said that in this case, we can write them in terms of mass multiplied by velocity, which is the linear momentum, and mass multiplied by acceleration, which is the force. Now, let's talk about linear momentum. We discussed it a little bit in the beginning of the class, and we discussed this formula, P is equal to mv. And of course, we know that velocity is a vector, and therefore P will also be a vector. But while solving problems, sometimes we don't need to give the vector notation. We can simply treat it as P is equal to mv without the vector consideration. Again, if we know the momentum, the change of momentum with respect to time is equal to the force. This is a second form of Newton's law. Newton's law can also be written in this form. This means the change in momentum per unit time is equal to force. So you can relate momentum with time. Now, if you have again like a system of particles, which we have been discussing. Now, when we studied the simple formula P is equal to mv, we were talking about a single particle. But now when we talk about a system of particles, so we have a large number of particles, let's say m1, M2, any body, the baseball bat, for example, can be considered as a system of particles. The human body, for example, is a system of particles. So then we have to consider all this and apply the formula to each one of them. So each one of them will be multiplied by the velocity of that mass, and you will sum it to get the total linear momentum. And hence the combined formula will become P is equal to capital M. Capital M is, as we have defined always, is the sum of all these masses, right? And then you sum them over all the masses. And like in the last equation, we said acceleration of the center of mass. Now we are talking about the velocity of the center of mass. Okay, so the center of mass acts like all the forces are acting on it. Okay, and therefore we can, these equations can be understood. So we studied that force net is equal to change in momentum, which is equal to this equation that we've just studied, and which is also equal to m multiplied by acceleration of the center of mass. And then for a system of particles, we get this equation, and this equation is another way of writing the second law of motion, Newton's second law of motion, right? Okay. Now, what is conservation of linear momentum? We talked about there are laws of conservation in physics, in mechanics, right? We have the law of conservation of energy, for example. What is the law of conservation of energy? Do you remember that? The law of conservation means that the total momentum of a system for a closed, isolated system in which there's no external interference will remain constant. This means that the initial momentum will be equal to the final momentum. Okay, so total linear momentum at an initial time, let's say t1, will be equal to the total linear momentum at a time, which is at a final time when you measure it, which is tf. Okay, now when this meeting ends, you can click again the same link. Okay.
Okay, ma'am.
Hamza, are you there? Hamza Dar? Hamza Dar, are you there? आवाज नहीं आ रही मुझे.
Yes, ma'am, I am here.
कितनी लेट आए हो तुम?
मैम मैं 15-20 मिनट से.
हाँ तो फिर आपकी अटेंडेंस तो नहीं ना होनी चाहिए.
मैम एक्चुअली वो लॉगिन नहीं था मैम.
क्या था?
मीटिंग में मैम लॉगिन नहीं था हो रहा, इंटरनेट इशू.
ये तो अच्छा बहाना है नहीं. Okay, now let's talk about, we talked about momentum. Now let's talk about kinetic energy and collisions. What are collisions? Can you give me an example of collision, Hamza Dar?
Ma'am, when two bodies collide with each other.
Example?
This is called.
Example?
Ma'am, like two balls or two cars.
हाँ, तो two cars collide करेंगी तो that's an accident, right? That's an example of an accident. And two balls collide करेंगे, it's possible that that collision is an elastic collision. So collisions are of two types. We have elastic and we have inelastic, right? So the billiard ball is a very good example of a collision of balls, okay? And the two cars colliding is an example of an inelastic collision. So how do you define elastic and inelastic collisions? We can talk about this. Number one, we know that momentum is always conserved in a collision. The initial momentum, we just studied the law of conservation of momentum, that the linear momentum at the initial time t is equal to the final momentum at the final time f, okay? Or if there are more than one bodies, we have a system of particles, the sum of all the initial momentums will be equal to the sum of all the final momentums. Now let's look at kinetic energy, what happens. So in this case, we can say that if the energy of kinetic and total kinetic energy of the system remains the same before and after a collision, then it is called an elastic collision. Okay, so this is the explanation here. But if the kinetic energy of the system changes, it does not remain the same, it is not conserved, then we call that collision not as an inelastic collision. For example, the accident of two cars, the colliding of two cars is an inelastic collision. Okay. So here we have a diagram where we can use this for explanation. So we have two masses, two particles, two bodies, right? M1 and M2. You can see that their masses are different. They're not equal masses, okay? So the body M1 has a velocity v1i and the body M2 has a velocity v2i. So the upper part of the diagram represents the initial part of the motion. So you have the subscript I. And afterwards they collide and then the body M1 starts moving with a velocity v1f and the body M2 starts moving with a velocity v2f. You will notice that the velocity has changed. You will see that v1i is not equal to v1f and v2i is not equal to v2f. You must again have noticed this when you play billiard balls, that depending upon how you hit the balls and the sizes of the balls and the masses of the balls, the velocities will be accordingly. And you can use these concepts in order to play the game effectively, right? So again, like we said, if the energy is lost, you know, for example, when two cars collide, a lot of energy is lost and in the form of, let's say, heat, right, and noise, and there are many other things happening, and therefore it's called an inelastic collision. But in other collisions like billiard balls, for example, there might be a very minor loss of energy, but we can neglect that and we can approximate that the collision of common bodies is elastic. Okay. So when we study in detail for inelastic collisions, looking at the diagram that we just discussed, we can write an equation to show that again the conservation of momentum. The total momentum before collision should be equal to total momentum after collision. So we have two bodies M1 and M2. So P1 plus P2 initial plus will be equal to P1 plus P2 fine. So we can put the values of P1 and P2 in terms of the masses and velocities, and we can write this equation. Okay. Now we can now talk about an inelastic collision, and again when we write that, we can say that if, let's say, the second body was at rest when we started the motion, initial velocity of the second body was 0, then the m2v2y term in the above equation becomes 0, and we are left with this. So in this case, the velocity can be determined with this equation. Okay, so in this one, the initial one was 0, and therefore, after collision, the two bodies combine together and start moving with the same velocity, which can be found with the help of this equation. So this then is the velocity of the center of mass, and therefore we can write this as velocity of the center of mass, and hence we can use this formula and these symbols. And now, talking about elastic collisions, in which we say that the total kinetic energy before collision is equal to the total kinetic energy after the collision, then we can write the formulas. This is for the momentum, which we just discussed above, and this is for kinetic energy, in which the sum of the initial kinetic energies is equal to the sum of the final kinetic energies. Okay, so here you have it, and this diagram is corresponding to these equations. You can see that the mass m2 is initially at rest. That's why on the left hand side we don't have the term for m2. And after collision, the bodies again change their velocities, but they do not combine together like in the case of the inelastic collisions. Okay. So using this, we can write and find the values for the final velocity for mass m1 and for mass m2. Now, these are some cases that you can look at. What happens if there are equal masses? Okay. What happens when the second mass is very large? And what happens when the first mass m1 is, the first mass m1 is called a projectile. Projectile is normally called the particle that is hit on the second particle, right? So this is, and the particle, the m2, the second particle is called the target particle. So this particle will go and collide with that particle, and therefore this is called the projectile, and the other one is called the target. So we can write these formulas, understand them, and then use them in solving problems. So I don't, we have completed the time of the class almost. So I don't think we need to have a second meeting now. Okay. Alina Khalida Ventaroli. Very nice. Okay. So these are the concepts that we will be working with. And in the next class, we will solve problems related to these concepts. Okay, so this is what we've studied today. I will post the marks of your midterm exam on Moodle. Okay, so you can see it from there. I will post it and I'll send you a notification. Also, yes, for your lab work today, I will upload the material for the lab, and please study it and practice. Study and practice the material uploaded. Okay. This is a part of your course, and you're going to get a credit for this. And I will also assess you for what you've done. Okay, so I will post this material, and please you study it and practice it around 2 p.m. Okay, keep your routine just like the normal regular classes we used to have on campus. Okay, is that okay?
Okay, ma'am.
Okay, right. So when this meeting ends, this will be the end of the class. Okay. So you're.
Ma'am, I'm left with the attendance. Rana Shahbaz.
राना शहबाज, तुम गायब क्यों होते हो? तुम पहले ये बताओ.
मैम इंटरनेट इशू था, मैंने बिल्कुल टाइम से ज्वाइन किया था.
अच्छा ठीक है, मुझे पता है. ठीक है.
ओके
ओके. सो आपने अब क्या करना है? लैब का काम करना है 2 बजे. अपनी रूटीन वही रखो जो नॉर्मल क्लासेस में थी, उसको ना खराब करो. ठीक है.
ओके मैम.
हाँ. एंड don't worry about the midterm marks. I think you performed well. Most students performed well. I'll post the marks on Moodle, and I'll let you know. And meanwhile, ये chapter